Hi everyone! Today we'll be talking about one of my personal favorite prototyping tools, Arduino. What's an Arduino? An Arduino is a type of microcontroller. This means it's essentially a small computer that we can program to run code on a loop. It's awesome for robotics or electronics projects in general. It's compatible with a wide range of electrical components and sensors, including motors, LEDs, microphones, ultrasonic sensors, and IR sensors. Even better, the software to run it is free. It's called Arduino IDE, and it's based off of C and C++ languages. But don't worry if you haven't coded much before. There's a guide online for most any sensor with example code. Once you get the basic structure of the code, you'll be ready to tackle a wide variety of projects. If you don't have access to a physical Arduino, Tinkercad.com has an excellent Arduino circuit simulator to practice with. A good place to start is with a servo motor. What's a servo motor? A servo motor is a motor that normally rotates 180 degrees. You can attach parts to it with different feet, also called servo horns. With our Arduino, we'll be able to tell the servo how to move and we'll be able to see our code in action. Let's get started. Arduino Unos have 13 digital pins and 6 analog pins. These are the pins used to receive data from or control other components. Arduinos have ground pins and a 5-volt pin as well. Here's how to wire the servo for this practice. The ground on the servo connects to ground on the Arduino, power to 5 volts, and the signal connects to a digital pin. I'm choosing number 7. Next, it's time to work on the code side of things. From Arduino's website, I'll download Arduino IDE and open it up. In case you're curious, IDE stands for Integrated Development Environment. It combines all the tools you'll need to develop code: the text editor, the compiler, a debugger, and so on. Here's what the Arduino interface looks like. The basic code structure is split into 3 main sections. 1. Before the setup. 2. The setup. And 3. The loop. We'll generally define our variables before the setup as a way to simplify what we're referencing throughout the code. Setup is a function or command that only runs once. Each time Arduino starts up, it will complete the information inside the curly brackets and move on to loop. Loop is a function that runs on a loop indefinitely. Note, void is part of the Arduino syntax. It means that we don't expect any information to be returned by these functions. Here's what a basic servo motor script might look like. We'll walk through it line by line. Pound include angle bracket servo.h angle bracket includes Arduino's pre-existing library of servo commands. There's a library for a lot of different components if you need them. Servo, myservo creates servo in the code. Note that the general practice here is to capitalize the second word in a variable name with multiple words. Int angle equals 0. This is our first variable. Int means integer, and angle is our variable. We'll use it to refer to the servo angle. By setting it equal to 0 at this point in the code, we're giving it an initial value. Same with int servo pin equals 7. We're initializing variable servo pin, so it's easier to keep track of what we're doing with the code, and easier to adjust later if we switch the pin we connect the servo to. Rather than having to find every 7 in the code and change it to the new number, we can just type the new number once, here in the very beginning. In setup, all we do is tell the Arduino that we've connected a servo using myservo.attach parentheses servo pin. In loop, we get to play around. To change the angle of the servo, we use the command myservo.right parentheses some angle. Here, I'll have the servo switch between 2 angles so we can see the code in action. We'll do angle and angle plus 15. We could write the 15 as another variable, but for the sake of brevity, I'll just add it here. After writing the angle, we'll wait for the servo to physically move using command delay parentheses some number. We'll use 150. Time in Arduino defaults to milliseconds. All the double forward slashes you see are comments. Little notes that you can write yourself that don't affect how the code runs, but help explain what you're trying to get the code to do. And be careful, the code is case sensitive. Once you have a code ready, plug in the Arduino. You might need to click Tools, Board, Arduino Uno, and Tools, Port, the appropriate port, to help the computer and Arduino talk to one another. Next, click the checkmark button. This is Verify. It checks your code for any syntactical errors. If it doesn't return any errors, click the arrow button. This is Upload. It uploads your code to the Arduino. Now watch the servo motor and see if it's moving how you'd expect. What gets more interesting is when we change the angle incrementally. Back in our code, let's make some changes. Rather than assigning a new number to the angle, we'll use a for loop. A for loop is a control structure. It follows this structure: for, parentheses, initialization, semicolon, condition, semicolon, increment, parentheses, some curly brackets with a statement inside. In this case, for the initial angle at 0, until the angle is less than or equal to 180, the angle increases by 1 degree. Each time it increments, we also write the new angle to the servo so it moves, and pause to let it move. Once it reaches 180 degrees, we exit that loop and enter the next one. For angle initially at 180, until the angle is less than or equal to 0, angle decreases by 1. This time, we decrement the angle. And just as before, we write the new angle each time and pause for the servo to catch up. With this code, the angle will oscillate from 0 to 180 and back again so long as the Arduino has power. And yes, that's neat, but what can we do with that? As a quick demo, I cut a strip of cardboard and scored it into 4 sections, kind of like a 4-bar linkage. I taped the servo to a corner and used a paperclip to attach it to the other side. And then added a little art to make it more interesting. Servos can be incorporated into all kinds of projects and used in really innovative ways. And the Arduino principles we talked about in this video apply to a bunch of other components too. I hope you enjoyed this video. Thanks for watching!